Hey, welcome back to Global Environment. Today we're going to talk about eutrophication, and to do that we're going to start out by looking at a system where no eutrophication is occurring. So we're going to look at Flathead Lake in Montana, and I want you to look at this beautiful scene. What do you see? You see a lot of blue water, beautiful blue water, so beautiful. In fact, one of my colleagues got married at this point right here. But what does that blue water mean? The blue water means low productivity. So there's a very low amount of algae growing in this system, not a lot going on. And in fact, it has its own word. It's oligotrophic. And this system is so oligotrophic, it's called ultra-oligotrophic. So low productivity. That means not eutrophied, which is important when we talk about eutrophication. Okay, so we generally like our lakes like this. Here is an example of a stream in upstate New York. Beautiful, clean, very clear. Again, low productivity, no eutrophication here. And I want to point out another concept related to this. It's the idea of an energy subsidy. If you look at that stream system and I were to ask you, where is the energy coming from that's entering the food chain in that system, you'd probably say, well, you know, the sun is shining and algae are growing and then, you know, zooplankton eat that and fish eat that and so on. But you'd be wrong, because the truth of the matter is most of the energy coming into the food chain in this system is from the surrounding ecosystem. So generally it's from photosynthesis, tree photosynthesis. The leaves fall off, they enter the stream, and that's where the energy is coming from. So this is important, the idea of a subsidized ecosystem, because when we talk about urban environments and industrial environments and even ocean fisheries, this idea of an energy subsidy is crucial. Okay, so let's talk about eutrophication now. What's actually going on? So in eutrophication, the productivity of a water system rises to great levels. And why is that? It's because of these two inputs mainly. The first one's nitrogen, and often that is due to fertilizer application through agriculture, when you put it on your lawn, golf courses, things like that, but also acid rain. So nitrogen that's released during combustion, often through automobiles, that can be inputted into systems. Another one is phosphorus, and when it comes to water systems, you know, like streams and lakes, it's the most important. This can be through sewage, waste, detergents used to have a lot of phosphorus in them, and this would really change systems. Livestock as well, not just people, but livestock help to input a lot of phosphorus. Okay, so once these nutrients enter the system, you get a lot of growth of algae, filamentous algae, also cyanobacteria, basically the producers of a system, and you start getting you know, this green color to your water systems. Okay, now eutrophication has really taken off over the last you know, 150 years or so, and we really saw an increase in it during the Industrial Revolution. Why is that? Because indoor plumbing started to become used heavily. Also, you think of open-ended sewers, you know, straight from the toilet into your waterway, causing large problems, nutrient loads that cause algae growth. Flushable toilet invented around 1900, and a population explosion. As quality of life improved, often through these, population grew and more stress on the environment. And to give you an idea how systems changed and how waterways were impacted, think of this. In 1835, there's about 350 people in Chicago. And about 20 years later, over 60,000 people. So, you know, several orders of magnitude, and several orders of magnitude more stress on the environment through nutrient loading. Okay, so if we go old style a bit, and talk about ecosystem goods and services like we did in the economics part, cleaning up water, cleaning up waste is something generally nature has done for free for us. And you know, you look at the system with a septic tank and a drain field, we get the environment to clean up the waste for us, again for free. But when you start stressing out the systems, you add more and more people, more and more livestock, and sometimes directly inputting waste into waterways. Nature can't handle that as well anymore. Okay, we mentioned population explosion, and you can see the magnitude of it in the United States over time, you know, going from about 50 million people, and now we're over 250 million people, you know, in less than 100 years. Big impact, more people, it's iPad all over again, the population part. Also, I mentioned livestock, and you look at here, we've got some pigs in the background, and you can see the growth in livestock as our affluence has gone up, again in iPad, our impact on the environment has increased. And it peaked just after 1970, it's kind of going steady, and you know, our livestock generally outweighs our human population by about 5 or more times. So, you know, the waste produced from livestock often goes directly into water systems. Okay, another big problem is our use of fertilizers. More people, higher affluence, we use more fertilizers to grow more food. That's a good thing, but as fertilizers are added, a lot of it leaches off directly into waterways like the Mississippi, and you can see for a long time that was rising. We've kind of leveled out, but again, this can contribute to eutrophication and that increased growth in algae and macrophytes and other things. Okay, so we're going to stop here for a little bit, come back and talk a little bit more about eutrophication and what actually happens to water systems that are eutrophied. So I'll see you next time.